Hello, and welcome to MVAO302, Configuring Total Object Manager, or TOM. MVAO302 is the last in an 8-part series of courses covering MainView AutoOPERATOR. The first area we're going to discuss is setting user preferences with TOM. TOM uses the CAS's HFS path to store the user preferences, which is also used by MainView Alarm Manager for the alarm definitions. If the HFS path is not specified in the CAS, you'll receive a number of different errors. TOM allows you to set preferences for confirmations and various different options in the panels. These include definitions for objects, sets, layers, TOM systems, object and calendar bases, and calendar entries. Here's an example of the TUPREF view used in MainView Explorer. You'll see a similar display in the 3270. The TUPREF view supports a number of different actions. The most important and probably the most frequently used is the edit primary command. Issuing the edit command will invoke a dialog that TOM will use to help walk you through the customization of your preferences. There's also a respref command that resets all of your user preferences to the default settings as distributed with TOM. Be aware that for edit and admin functions, that this will reset the object and calendar definition bases to the active bases. There's also a clear pref command that will clear and delete all user preferences. And again, for edit admin functions, your bases will be set to the active ones. TUPREF also supports line commands for the preferences. The res or reset command will reset a user preference to its default setting, and the CLR command will clear or delete a user preference. A note for both these commands, as we saw for the primary commands, your edit admin definition bases will be set to the active values. Let's walk through modifying user preferences using the 3270 interface. The first thing we're going to do is on the command line, we're going to type in edit to begin the dialog to modify the preferences. Once you type in edit, you'll see TOM pops up a window asking you for what types of entities do you want to modify the preferences. In this case, we're going to select objects, the first entry. TOM will pop up a window that will let us select what it is that we want to change in the preferences. At the top, we select what we want in terms of confirmation displays, and then at the bottom, we will select what it is we want to change in terms of the command options. Here we see the various options that you can specify with the reset command. So instead of having to go in and select these options every time you issue the command, you can use the user preferences to pre-populate these fields so that when you issue the reset command, these options are already selected for you. Now let's take a minute to talk about managing definition bases. As you've probably surmised, TOM stores all of his object, set, and calendar definitions into what we call bases. And bases come in two flavors. We have object definition bases, which includes your sets and your layer and objects. And then we have calendar definition bases that contain your calendar dependencies. Please be aware that only one of each can be active at a time within a TOMplex. Now, it is common to have multiple definition bases defined so you can accommodate different situations. One of these is when you want to build a disaster recovery definition base that maybe only brings up the base system instead of all the CICSs, DB2s, and what have you. That's one instance. Another instance you may want to use additional definition bases is so that when you implement changes to objects, you can test them before migrating them into your production definition base. TOM uses a registry to store these definition bases, and by default, when you implement TOM, you will have two. For the object definition base, you'll have one called default, and for the calendar definition base, you'll have one called default cal. All the definition bases are stored in the TOM Registry. The TOM Registry is a data space that is backed by a VSAM linear dataset, and it contains all the object definitions, whether they're calendar entries or objects or sets. This information is preserved across IPLs, so it's very persistent. And every TOM needs to be constantly updated about the status of all objects in a TOMplex, so they share a registry. A TOM uses RTCS to manage its registry, so if he needs to make updates or changes, he makes calls to RTCS to do so. And modifications to the TOM registry is communicated by XCF within a sysplex. Be aware that one TOM in the TOMplex is the owner for update purposes. It generally is the first TOM that comes up. If that TOM goes down, then the ownership is passed to another TOM in the TOMplex. TOM provides several mechanisms for managing the registry. There's a registry dump command that you can issue from within the TOM interface, although TOM also provides for periodic dumps to be taken automatically. This is something that is specified within the TOM parms. Typically, the registry is dumped either once or twice a day, although it is dumped whenever you restart the TOM paths. You can also manage the TOM registry by using MVI deployment commands, using tag and deploy. And there is a utility exec that's distributed with TOM called MAM-EXPRT that you can use to import and export the definition bases from the registry. It is important that TOM's registry is large enough to hold all of the object definitions that you need. TOM uses approximately 20 megabytes of registry for each 100 objects that he'll be managing. And TOM registry is typically shared throughout the TOMplex, which is generally the same as your sysplex boundaries. So make sure you account for all of the objects on all of the LPARs when you're sizing the registry. Now you can check the size of the registry by issuing a modify against TOM, registry space display, and that'll show you how full your registry is. And if it's getting too full, it is possible to resize the registry by allocating larger data sets. BBSAMP member Tom Alec has JCL that you can use to allocate the registry that Tom requires. It'll also allocate the backup for the dumps of the registry. Now, when you do your initial install of TOM, this is part of the basic customization, so you shouldn't have to worry about it. Here we see an example of the TDEFBS view, which is used to manage your definition bases. And here's an example of the TDEFBS view in MainView Explorer. The TOM TDEFBS view supports the following primary commands. Add allows you to create a new object or calendar definition base. The deploy command deploys a tagged object or calendar definition base to another definition base. That definition base can be the active one, an existing one, or it can be a new definition base. The deploy can be to the local TOMplex or any TOMplex that's connected within the MainView CASplex. So it requires CAS to CAS connections to get to the remote TOMplexes. And then there's a tag clear command that will clear all of the tag definition bases. The TDEFBS view also supports several different line commands. The SWT command switches to a different definition base for editing. That does not impact what's currently being used to manage the system. It's just for your editing session, so you can go in and modify objects without impacting the running system. There's a delete option that deletes a definition base, although you cannot delete the active definition base. There's an REP command that allows you to repeat or make a copy of a definition base. The RES command resets the control mode or the IPL counter for each of the objects in the definition base. The ACT command activates a definition base, which causes the objects in that definition base to become actively managed. There's a tag command that allows you to tag a definition base for deployment. And there's a val or validate command that allows you to test your calendar-based definitions. Now let's take a closer look at calendars, and in particular calendar dependencies. So schedules are what govern when an object should be active in TOM. An object that does not have a schedule will be active 24 hours a day, 7 days a week. Calendar dependencies can be created for object attributes such as start, stop, retry commands, or when you want to run execs. So you can conditionally run those depending on day of week or time of day. You can also specify calendar overrides that are exceptions to the normal calendar dependency. We'll show you an example of how we build that in a couple slides. When you first implement TOM, you'll notice that he has in his registry a pre-populated calendar definition base called default cal. There are also additional names that are reserved, including active, base, calendar, and default. The calendar definition base contains 4 types of entries. The first type we're going to talk about is the day type. And the day type of entry is a collection of days. You can give it a 1 to 20 character name and including blanks. And what it essentially does is you're building a collection of different days of the week. Now, Tom provides some pre-populated values, including 1 for each day, 1 for weekends, 1 for weekdays, and then 1 for daily to include all days of the week. The second type of calendar entry we're going to discuss is the time entry. And the time entry is used to specify a time of day or a period of time of day, such as 2 a.m. to 5 a.m., right? What we do is we specify the from time and the to time, and you are allowed to span midnight. So what Tom will do is if you go past the 24-hour mark, he will add 1 day to the time. The third type of entry we want to discuss is the period entry. And the period entry provides a means for you to specify a from date and a from time and a to date and a to time. Now, like we saw for the other calendar entries, you can specify any name, 1 to 20 characters, including blanks. And Tom always pre-populates the calendar bases with an entry called always, which covers all time. The last calendar entry we want to discuss is the set entry. And a set entry is just a combination of periods, days, and times that you want to layer together to build a more complex availability schedule for your objects. Now, these entries are grouped together using AND logic, okay? So if you want to use OR logic, then you'll need to do something a little more sophisticated. Here's an example of the T-calendar entry view, which contains all of your calendar definitions for all different types. The TOM calendar entry view supports several different primary commands. The first primary command is the add command, which is used to create a new calendar entry in the calendar definition base. There's a deploy command that allows you to deploy tagged calendar entries to another definition base, and that definition base can be the active definition base, it can be an existing definition base, or it can be a new definition base. You can also use the TOM to deploy your calendar entry to other TOMplexes so long as they're connected via the CASs. There's a tag all command that allows you to tag all of your calendar entries for deployment, and a tag clear command that removes all of your tags. The TOM calendar entry view also supports these line commands. You have the del or delete command to delete a calendar entry. If you want to edit a calendar entry, you can use the edit command or E. If you want to copy a calendar entry, you can use the rep or repeat command. And if you want to tag a calendar entry for deployment, you can use the tagline command. So let's walk through an example of adding a calendar entry. So from the TOM calendar entry view, we're going to type add on the command line. And TOM will display a window like this. So in this case, we're going to add a time entry. So we're going to select time and press enter. And on the subsequent panel, we'll specify the time period that this calendar entry applies to. So now let's go ahead and let's create a set. So we're going to select set. And then you can see on the subsequent display we have 0 set members. So we're going to edit that. And Tom will show us the members in the set. Well, we don't have any, so we're going to do an add command. And Tom will show us all of the calendar entries that are available. Now in this case, we're going to select office hours and weekdays. And you can see Tom adds those calendar entries to his set. So sets can apply to calendar entries, but they also can apply more commonly to objects. Reasons you might want to use a set is like to group all of your CICS regions together, or maybe you want to group your objects or CICSs, DB2s, IMS, whatever, by the applications. And the reason you might want to do this is so that you can issue one command and it'll go ahead and take that action against all of the objects in the set. Now sets can be defined to contain other sets, so you can nest them up to 16 levels deep. So like objects, sets can be managed through multiple interfaces in TOM. You can use the TOM online interface, you can manipulate sets using execs, and you can use console commands by issuing modifies against TOM. Note that when you're interacting with sets and objects that are running on multiple systems, you have to specify the host and apply that command to each of the hosts. The easiest way to do that is to use an exec and run through the process repetitively. Here's an example of the TOM set view called TSET. And here you can see a list of all the different sets that are defined to TOM, as well as the number of members contained in each set. The TOM TSET view supports several different primary commands, the first of which is the add command, which is used to create a new set. The deploy command deploys tag sets to another definition base, and again, that definition base can be the active definition base, it can be an existing definition base, or it can be a new one. The deploy command can be used to deploy to either the local TOMplex or to a different TOMplex so long as it's connected via CAS connections. There's a tag all command that tags all of the sets, and there's a tag clear command that clears all of the sets that have been tagged. The TSET view also supports several different line commands. You can delete a set using the del command. If you want to edit or modify a set, you can use the edit command. The rep command creates a copy of a set. The tag command tags a set for deployment for use with the deploy command. If you want to browse a set, you can select it with an S. The OPR or operator command will display a list of all the operator commands that are typically issued. You can do an RES or reset to change the object's control attributes in the set. If you want to bounce all of the objects in a set, you can use the BOU or bounce command. If you want to shut down all the objects in a set, you can use the shut set command. If you want to move all of the objects in a set to a different system, you can use the move command. If you want to stop all of the objects in a set, you can use stop, and you can use start to start all of the objects in a set. Additional commands. You can lock objects, which says keep them inactive until I IPL. An unlock is the reverse of a lock. A block command will stop all of the objects and keep them inactive until they are explicitly reset or unblocked. There's a suspend command that says, Tom, I don't want you to manage this object anymore. And then unsuspend does the reverse of a suspend. Let's walk through an example of creating a new set. From the TSET view, we're going to type add on the command line and press enter. Tom's going to ask us to give a name to the set. In this case, we'll call it My Favorite Objects. And then we'll give it the description. and we'll see a list of all the objects that are contained within the set. Now in this case we don't have any, and what we're going to do is we're going to add new objects. So we're going to type AO on the command line, although I want you to point out to you that you can also use the AS command if you want to add a set to this set. So we type in the AO to add objects, we'll be presented with a display like this. Now, if you have a lot of objects defined in your definition base, it can be easier to use this filter to limit the display so you can find the objects you're interested in. So in this case, we set a filter looking for objects that end with GA, and we're going to go ahead and select all of the ones we want to include in the set. This concludes MVAO 301 Part 1.